So you may have noticed when we created the vehicle class in the last video that if we did not run or call the initialize function, that there was garbage in the variable. So we need to be able to initialize those variables in the class somehow. And here's an example of one way to do it. You can just declare and initialize those variables right there in the class itself. That way, if I were to create a new class object or instantiate an object of the class like Peterson, it is automatically going to have those default values. So that is one way that I can get initials or initialize those variables, but there are better ways to do it. And what they are called are constructors. So next we're going to introduce you to several utility functions. That is my word, utility functions. One of those utility functions are constructors, and then we'll also be talking about getters and setters. So how about if we talk about constructors first? So here's an example of a constructor. I want you to notice that it is going to be public. It has no return value. It must have the exact same name of the class, letter for letter, upper and lower case. And it has no default value. So I would just the name of the class along with the parentheses, so that when I instantiate a class object such as Peterson, it will run this constructor automatically, but my constructor has no values, right? As a matter of fact, if I don't include a constructor in my class, the system will automatically give me an implicit constructor just like this with no default values. But if I want to have default values in my constructor, I can actually do that with an initializer list. So here's an example of a constructor that now has 3 parameters, the same 3 parameters that are my instance variables or the variables in the class. And the initializer list is the parentheses with the comma separated parameter list followed by a full colon. And then we are going to assign name, the parameter name. We're going to assign the instance variable called pay grade to the parameter pay. We're going to assign the instance variable balance due to the parameter balance due. And then I want you to notice that there are the curly braces at the end of this, and there are no semicolons. I should mention that. All right, so this is what it might look like if I'm going to use a constructor with an initializer list. So when I instantiate an object called Peterson, I'm going to pass to it 3 parameters, and those parameters are then going to be used to set the arguments for the class values. Now I want you to notice that if I'm going to declare my own constructor, then I cannot use the default constructor, so I would have to comment this out if I happen to have one. So if a user-defined constructor is declared, there can't be a default constructor anymore. So here's an example of a constructor that is using an initializer list. I can also give initial values to these parameters. We have done that before. Here's an example of setting an initial value for name, pay, and due. So I'm just going to initialize or give default values to those parameters, and then I'm going to use the initializer list to set those. So once again, if I just instantiate an object with no parentheses and no values, it will use the default values. But if I pass to it 1 or more of the parameters, of course in the correct order, then it's going to override any of those default ones that I might have. Now, of course, we could actually give default values to our variables using an inline function. So here's another example of a constructor that has no parameters, and so I'm just going to default those 3 instance variables to default values. I'm going to do it inline. Now, this makes the class less flexible than if I were to define my functions on below the class itself. It makes it much less flexible. So this is what my, if I'm instantiating an object of the class Peterson, it's just going to set it to those default values. All right, so several of the other utility functions that I had mentioned before were getters and setters, right? They can also be called accessors and mutators because they allow you to access or mutate your instance variables. Remember, I said that for the most part, your variables are going to be private because you're going to want to control the access to it. I don't just want to randomly allow people to set them or to do things to them without some kind of constraints in place. And so I might create some getters and some setters. So here's an example of a couple of getters. Because maybe I want to allow my user to be able to see or retrieve the value in name and balance due. So I'm just going to declare a couple of getters. I'm also going to declare a couple of setters. So I'm going to allow them to set their name and their balance due, but maybe I'm not going to allow them to set the pay grade. So I'm going to create getters and setters that allow them to retrieve the values from the instance variables that I choose and then set or manipulate the values in other functions that I would choose. And this is what it might look like. If I'm using a getter, I need to capture the return value. If I'm using a setter, I have an instance variable, an object that I am using, like Peterson, that is calling those functions, and then we're going to pass something to it, an argument to it. Now, many of the normal functions that we're going to create in a class are naturally getters and setters, and they might have other names. For instance, pay, parking, ticket is actually a setter for balance due because it's probably going to reduce or increase the balance due. And so I would call it pay parking ticket versus set balance due. The getters and the setters are a way that I can override the initial or the default values that I give it. Anyway, it's up to you to decide about getters and setters.